Hello students, in previous class I have discussed about unit and dimension. Previous class we have learned that what is the physical quantities, what is the dimension, how you calculate the dimension of a unknown quantity, and what is the application of dimensional equation. Today we will discuss the problem about dimension, unit and dimension. Here I have discussed type by type problem. If you solve this problem properly, then you can answer any type of problem in this unit and dimension chapter. If you solve this problem, then you will able to solve any types of question related to unit and dimension. So here three types of question are given. Type 1, calculate the dimension and unit from a equation. This is the equation, this is also equation, this is also equation, this is also equation, here this is the equation, here is the equation. There are many types of equation. From this equation you can calculate the dimension and unit of unknown quantities. For this you have to learn that the homogeneity of a equation. What is the homogeneity of a equation? Homogeneity of equation is means if x equals to y plus z and x equals to y minus z, then this quantity and this quantity must be same, also must be same in nature. That means you can only add two similar, two or more you can add or subtract two or more similar quantities. That means you have 7 kg equals to 3 kg plus 4 kg. That means if this is a kg, that means if this is a mass can be added only with mass. That means similar quantity can be added, but also similar quantity can be subtract. So you have to mind it that only similar quantity can be added and subtract similar quantity, but division and multiplication can be any types of quantity. You can multiply kg with meter square. This is the multiplication. You can also divide kg by meter, but you can only add two similar quantities and subtract two similar quantities. This is the theory of homogeneity. So you have to mind it that only similar quantity can be added or subtract, and multiplication and division can be performed in any number, any quantities, with any quantities. So we solve first problem, type 1 first, type 1 first problem. Here, if x equals to at plus bt square, here is the equation, x equals to at plus bt square. This is a equation where x is displacement, distance means dimension L, and t is time, and t is time. Then you have to find out the dimension of A and B and unit of A and B. Now, only similar quantity can be added or subtract. Here, this quantity must be similar to this quantity. That means dimension of x must be dimension of at, and also dimension of x must be equals to dimension of bt square, because similar quantities can be added. This quantity equals to this quantity plus this quantity. That means if this is length, this also be a length, this also be a length. So the dimension of x is L, then unknown quantity is A, the dimension of t is t, this is the time, dimension of time is t, then dimension of A equals to L t, that means L t to the power minus 1. This is the dimension of A. Also, this is the dimension of x is L, and here the unknown quantity is B, and dimension of t is here capital T. Then dimension of B equals to L by t square, that means L t to the power minus 2. You can easily calculate the dimension of A and B with the help of equation of homogeneity. Here the unit of A will be unit of A equals to L means meter and second inverse, and here unit of B will be unit of B equals to meter second inverse 2. This is the first problem. Then what is the second problem? Here is also a equation. Second problem, type 2, second problem. This is the first problem, I solve it, and second problem. What is the second problem? Second problem is given that velocity v equals to at plus b by t plus c, where v is velocity. Velocity means displacement by time, that means L t to the power minus 1. Dimension of velocity is L t to the power minus 1, and t is time, that means dimension of t is t, capital T. Here also you can notice that this quantity C is added with T. So this must be a similar quantity. C and T must be a similar quantity, because only similar quantity can be added. So dimension of C must be a dimension of T. Here you notice that C is added with T. So only addition can be performed with similar quantities. So the dimension of C must be a dimension of T. That's why it will be a function T, dimension T. That means unit of C will be second. And here this quantity must be A equals to this quantity. Dimension of V must be a dimension of AT, because this must be A equals to this. Here only velocity can be added with terms of velocity. That's why the dimension of velocity must be A equals to dimension of AT, and also dimension of V equals to dimension of B by T. This dimension is only T, because these two dimensions C and T, the dimension of C and T must be a T. And here the dimension of V equals to L T to the power minus 1, and here the unknown number is A and the dimension of T is T. Then the A equals to L T to the power minus 1, and here is another T, that means L T to the power minus 2. That means unit will be meter second inverse 2. And here the dimension of V equals to L T to the power minus 1, and here B is unknown, here is T, another T, and L T to the power minus 1 equals to, that means B unit of dimension of B equals to L. B equals to L, that means unit of, because T and T is cancel out, that means unit of B is meter. This T and C both have dimension T. That's why I have written that B by T. This is the second problem. Then what is the third problem? Third problem is, the equation is, this is another equation. What is the equation? Third problem, equation is P plus A by V square and V minus B equals to constant. Here P is pressure. Pressure means force divided by area. That means force by area, L square. That will be M L to the power minus 1 T to the power minus 2. Then what is the unit dimension of P? Pressure means force by area. Force equals to mLT to the power minus 2, and area is L square. That means dimension of pressure will be mL minus 1 T minus 2. And V is volume. Volume means LQ. Dimension of volume is LQ. Now here you see that this term is added with P. That means dimension of P must be equals to dimension A by V square, and also the dimension of V equals to dimension of B, because B is subtracted from V. So this quantity and this quantity must be similar, and also this quantity and total this quantity must be similar quantities. And here you see that the dimension of P is m L to the power minus 1 T to the power minus 2, and the unknown quantity is A, and dimension of LQ square, that means this will be m L minus 1 T to the power minus 2 equals to this by L6, because L or Q, that means L to the power 6, that means A, dimension of A must be m L to the power 6 minus, that means 5, and T to the power minus 2. Unit will be meter, kg meter to the power 5 second inverse 2, and here the volume is LQ, that means dimension of B is LQ, that means unit will be meter cube. This is the third problem. And fourth problem. What is the fourth problem? Here also a equation. Fourth problem, the force is F is AT plus BT square, where T is time. We find out the dimension and unit of AB. That means F is equals to AT plus BT square. Here F is force. Force, the dimension of F equals to mLT to the power minus 2, and T is time. Dimension of T is capital D. Then this dimension of force must be equals to dimension of AT, and also dimension of F must be equals to dimension of BT square, because this term is added. So dimension of F is mLT to the power minus 2, and here A capital D. Then A, dimension of A will be mLT to the power minus 2 divided by T, that means mLT to the power minus 3. This is the dimension of A. Then unit will be kg meter second inverse 3. Then here mLT to the power minus 2, then will be a B T square, and dimension of B will be mL T to the power minus 2 and T square, then will be mLT to the power minus 4, then T square 4. That means unit will be kg meter second inverse 4. This is the fourth problem. Then go to the next problem, which is problem number 5. What is the problem number 5? Here distance y is a distance, y equals to a sine omega t minus kx. Here t is time, the dimension of t is t. Y is distance, the dimension of y is L, and x is also a distance, that means L. You have to find out the unit of a omega and k. This total is a unitless quantity. Because theta is r by arc by radius. That means r by r, that means l by l, that means no dimension. This total quantity is a dimensionless. So this quantity and this quantity have dimensionless. This quantity and this quantity is a dimensionless. That means dimension of omega t must be a dimension of m to the power 0, l to the power 0 and t to the power 0. What is dimensionless? Then omega, here is t equals to m to the power 0, l to the power 0, t to the power 0. The dimension of omega will be m to the power 0, l to the power 0, t to the power 0 divided by d. That means t to the power minus 1. Unit will be second inverse. And also kx must be a dimensionless quantity, because dimensionless quantity here is m to the power 0, l to the power 0 and t to the power 0. Here k and x is l. That means m to the power 0, l to the power 0, t to the power 0. That means dimension of k will be m to the power 0, l to the power 0, t to the power 0 divided by l. That means l inverse. The unit will be meter inverse. This total quantity a unitless, also a unitless. This total quantity also a unitless. That's why the unit of y must be unit of a. That means unit of y equals to unit of a. That means this will be also a l. That means unit will be a unit will be meter. This is the question number 5, problem number 5. Then go to the problem number 6. Then go to the problem number 6. Here is the exponential term. This is a sine function. Similarly, you can calculate the cos function, tan function. And here is the equation, various types of equation. Here is a exponential series. That means 6 is p equals to p0 e to the power minus a t square, where t is time, here t is time, that means t. And this quantity, both this total is a unitless quantity, and also this quantity must be a unitless, only a number. So a t square dimension of a t square must be a unitless, because this is only number, e to the power 2, e to the power 3, e to the power 5, only a number. So a t square equals to m to the power 0, l to the power 0, t to the power 0. That means dimension of a will be m0, l0, t0. That here will be t square. That means t to the power minus 2, and unit will be second inverse 2. And dimension of p will be similar to dimension of p0. This is the 6th number question. And here I have completed the all question of type 1. All question of type 1. These are the type of type number 1, if you understand this 6 problem, then you will able to answer any problem related to this function. Now problem type number 2. Here unit and quantity, fundamental quantity, is an arbitrary function. If velocity, time and force are the fundamental quantities. What is the fundamental quantities? Here number 7, velocity, time and force. These 3 is a fundamental quantities. If you know that the mass, length, time is a fundamental quantity, but if you take this is a fundamental quantity, then what will be the dimension of density? What will be the dimension of density? What will be the dimension of density? That means density, say density is D. You have to calculate dimension of density in terms of velocity, time and force. Velocity, time and force. So you say that D equals to K V to the power A, T to the power B and F to the power C. Here K is unitless constant. Here is K is unitless constant and D is the density. You have to calculate the value of A, B and C, because you have learned that the dimension of derived quantity is expressed in terms of fundamental quantities. Here density is a derived quantity in this problem, and VTF means velocity, time and force is a fundamental quantities. That's why you have to calculate the power of V, power of T and power of C. Then you take this equation as follows. Then put the dimension of these quantities. What is the dimension of density? Density means mass by volume, mass by volume, density. That means mass M, volume means LQ, that means M L to the power L minus 3. This is the dimension of density. That means here will be a M L minus 3 equals to, this is the unitless, that means dimensionless case. And what is the dimension of velocity? Velocity dimension L T to the power minus 1 whole to the power A. And what is the dimension of time? In also a time, only T. B. What is the dimension of force? M L T to the power minus 2. C. Here I have put that I put the dimension of density, dimension of velocity, dimension of time and dimension of force. And here M L to the power minus 3 equals to, here is L, here is L. That means L to the power A plus C. A plus C, because here is L to the power A and here is L to the power C. That means L to the power A plus C. And M, here is there is nothing, M to the power C, and L T. Here is minus A, here is B plus B, here is minus 2C. This is the equation, and you have to compare the power of this side and this side. Here the power of L is A plus C, and A plus C must be power of this, that means A plus C equals to minus 3. Here is power of M is C, that means here is power of 1, that means C means 1. And here is T, power of T is 0, power of T is 0, that means the power of minus A plus B minus 2C, this is a 0. This is the 3 equation. There is a 3 equation. Here I compare the power of this side and this side. Here the power of L is A plus C, here power of L is minus 3. This must be equal. Here is power of M is C, and here is power of 1, that means C equals to 1. Here is power of T is minus A plus B minus 2C, this will be here. This is equation, that means C equals to 1. This implies that A equals to minus 3 minus 1 equals to minus 4. From this equation you can calculate the value of B. B means 2C plus A. B means B equals to 2C plus A. That means what is the value of C? That means 2 plus minus 4, because now A is 4 minus 4 and C is 1, that means 2 minus 4 equals to minus 2. That means density, dimension of density equals to V to the power A means minus 4, V to the power minus 4, T to the power B is minus 2, and C to the power F minus F only 1. This is the dimension of density in terms of velocity, time and force. Velocity, time and force. This is the problem